Hi, this is Mr. Sullivan, and today we're going to look at Factoring 101 Part 3. This is a special case, factoring the difference of two perfect squares. First, we're going to look at this interesting thing that happens when you do the distributive property in cases that look like these. If you look at these all very carefully, you're going to notice that they all have some repetition going on. The only difference between this binomial and this binomial is one is addition and one is subtraction. That's the same for all of these cases. So something very unique happens in that case. When I use the distributive property, I'm going to distribute the x first. So I multiply x squared, right? X times x is x squared. And then x times this minus 3 will get us a negative 3 or a minus 3x. Now I distribute the 3. Positive 3 times x will give us a plus 3x, and positive 3 times negative 3 will give us a minus 9. Okay, when I multiply a number by itself, I get this thing called a perfect square. And the interesting thing that happens here is that since these numbers are the same and one is positive and one is negative, when I try to combine these two terms, I get x squared plus 0x minus 9. Now 0x means 0 times x, or 0 times any number. So we know from the properties of 0 that when I multiply any number x times 0, I'm just going to get 0. So this term ends up canceling out, and my final answer is x squared minus 9. So this doesn't look like the answers we've been getting for other problems where we multiplied two binomials. So when you're factoring, you have to look for this kind of setup. And you have to ask yourself, is this number a perfect square? If it is, your factoring is going to go from this back to this. So you have to keep your eye out for it. So the same thing is going to happen here. X times x is x squared. X times negative 6 will give us minus 6x. Positive 6 times x will give us plus 6x. And then again, I'm going to get a perfect square because I'm going to multiply 6 times 6, only it's a positive times a negative, so this will be minus my perfect square, minus 36. These two are going to cancel each other out. I'll get x squared, and you do not have to do this step. You can just go straight to x squared minus 36, because we know that this term will cancel out. This is called the difference of two perfect squares, because subtraction is, to find the difference in math, you use subtraction. And x times x is a perfect square, x squared. And 36 is a perfect square because of 6 times 6. Now this one is reversed. I have minus then plus. But the same thing will happen. X squared, right, plus 5x, minus 5x, and then minus 25, again, because I have a positive times a negative, or a negative times a positive. These terms will cancel out, and my final answer will be x squared minus 25. Here, if you notice there's a coefficient in front of the x. Doesn't matter, it's still going to give you a perfect square because this is the same term as this. So 2 times 2 is 4, x times x is x squared. And now I have to distribute this 2x to the negative 9, so I'll have a negative, because a positive times a negative will give me a negative. 2 times 9 is 18 times x, 18x. And then I'll have plus 9 times 2 is 18. And then minus 81. These will cancel out, and your final answer will be a difference of two perfect squares, x squared minus 81. So all you have to do is recognize them. I see two perfect squares here. I see difference. I want to go x plus x minus, and now all I have to do is think about it. What two numbers multiply to give me 49? You can go through it. 1 times 1, 2 times 2, and you'll find that it will be 7. So this becomes your final answer. This is how we factor something that looks like this. Try it out with these. Think about what is the square root of each of these numbers, and make sure you put it into this format And at the end, you can check your answer by multiplying using a distributive property. Good luck.